Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science in Institute of Aeronautical Engineering, Hyderabad. So in this video, I'm going to discuss about the graph isomorphism. So what should be the essential concepts of graph? And very first thing is that a graph, what is a graph isomorphism? So let us consider a graph G1, so which is going to have the vertices V1 and the edges E2 set. And similarly, I'm going to consider another graph, so V2 and E2. So edge set are said to be isomorphic if and only if. So there should be one-to-one and onto function from V1 to V2 with the property that so A and B are adjacent in G1 if and only if f of A and f of B are adjacent in G2 for all in B and V1. So the function f is called isomorphism. So normally this one is going to be applicable in chemistry to find the two compounds that is going to have the same structure. So let us consider a graph. So for this, so A is 1, B is 1, C and then D. So this is the graph G1. Now I'm going to consider graph G2. So these are the two graphs what I'm going to consider. Is said to be isomorphic if and only if there should be a one-to-one and on-to function here. So this A and B are said to be adjacent if and only if f of A and f of B are said to be adjacent in G2. Then only the function is mapping what we called as isomorphic function. Suppose if there is an edge from A to B, so in G2 also there should be an edge from X to Y. If I am going to have an edge from C to D, so I'm going to have edge from Z to W. So if I'm going to have an edge from B to C and Y to Z are same, then two graphs G1 and G2 are said to be isomorphic. So normally this thing is going to be used whenever I'm going to have in chemistry. So if I'm going to have the compound events of the same structure. And representation example. So here if I'm going to have the graphs G1, G2, like so f of u1 equal to v1. So this is the graph G1 and this is the graph G2. So the function f of u1 that should be corresponding v1 and f of u2 that should be corresponding v4 and f of u3 v3 and f of u4 it should be v2. So this should be the same, like how we're going to represent this. So this one what we called as isomorphism. So whenever the two graphs are said to be equal, the function f is said to have isomorphic graphs. And connectivity. So the basic idea is that in a graph reachability among the vertices, so by traversing the edges. So example is that so in a city to city road network, so one city can reach from another city, and the problems if, if determining whether the message can be sent to between the two computers using intermediate links, and then efficiently the planning routes of the data delivery in the internet. So normally this connectivity is going to be important so for any kind of application. So graph reachability also the among the vertices we can able to done by traversing the edges. So efficiently planning routes for the data delivery in the internet is one of the example, and the problems of determining whether the message can be sent to the another computer using the intermediate links, and in city to city road network, one city can be reached from the other city or not. So for that, the connectivity through the path. So path is nothing but the sequence of edges here that begins at a vertex of the graphs and travels around the edges of the graph. So always connecting the pair of adjacent vertices. And so here, if I'm going to represent this graph, so set of vertices and edges, and the path is going to be represented as u1, 1, 2, 1, 4, 4, 5, and then 5. So in this graph, this is the path one of that. So 1, 4, 1, u1, 1, 4, 4, 5, and 5u. So like this, I'm going able to represent this path here. Suppose this is one source, and this should be the destination. So what is the path in between the source and destination to reach that? So for that, this is the one path. So reaching the vertex v1, v4, v5, and then 5v. So this is the path. Suppose similarly, the graph looks like this. So what is the path I can able to reach from u to v? So one of the path make it become so u to 4, 4 to 5, 5 to v. This is also another path, and another path is that u1 to 1 and 1 to 2 and 2 to v. This is the another path. Otherwise, I can able to go for another path is that u1 to 1, 1 to 4, 4 to 5, 5 to v. Similarly, u to 1, 1 to 4, 4 to 3, 3 to 2, and 2 to. So like this, I can able to establish many paths if I'm going to have from one vertex node of the graph to the other vertex of the node. So what is the definition of this directed graph? So a path of length n greater than 0, so from u to v in the graph in the sequence of edges such that therefore e1 should be x0, x1, and therefore e2 should be x2, x1, x2, so on. And the path is said to be pass through x1 to xn, or you can able to traverse from e1 to en. So for simple graph, the sequence is same, and then in case of circuit and cycle, so this u and v should be equal if the path should be greater than 0, and simple path is the path that does not contain any edge more than once. Then only I can able to say that that should be the simple path. And undirected graph, so undirected graph is the connected. So if there exists a simple path between every pair of vertices. So connected graph is that, so if there is a graph, so there should be a connection for each pair of vertices. There should be, if there is an edge from each pair of vertices of the graph, then I can able to say that there should be a connected graph. So undirected graph is also said to be connected if there exists a simple path for every pair of vertices. Undirected graph. So undirected graph is said to be connected if there exists a simple path between every pair of vertices. So in this representation, so this is the undirected graph. So there exists a path from v1 to v2, v3, and v2 to v3, v3 to v4, and v1, v4 to v5. So then I can able to say this should be the point. Similarly, there should be an articulation point, what we called as a cut vertex. So removal of vertex produces a subgraph with more connected components than in the original graph. And this removal of a cut vertex from the connected graph produces the graph that is not connected. And cut edge means that the edge whose removal produces a subgraph with more connected components than in the original graph. So here the representation example is that, so G of v comma e, where e v3 is the articulation point or edge, where the number of components is. So this is one edge, and this should be the under edge. So the cutting edge is that, so if I'm going to make this, and This should be called as an articulation point or cut vertex. What is this directed graph? So a directed graph is strongly connected if there exists a path from A to B and from B to A also, whenever A and B are the vertices in the graph. And a directed graph is said to be weakly connected if there is a path between every pair of two vertices in the undirected graph. A strongly connected graph can be weakly connected, but the vice versa is not possible. So a connected graph is said to be strongly connected if there is a path from A to B and from B to A. So whenever A and B are the vertices in the graph. And a directed graph is weakly connected if there is a path between every pair of vertices in the path. So next one, undirected graph. Directed graph. So here G1 is strongly connected because there exists a path from every pair of vertices, and G2 is weakly connected because not that much fully connected, so because of these directions. And in G3 is undirected representation of that, that's why it should be strongly connected. So how can I able to say that in directed graph is strongly connected components? So these are the subgraphs of the graph that are strongly connected. So representation is that G1 is the strongly connected component in G. So in this graph, so G is the G1 is a part of that which is going to be exist here. So that's one also I can able to say that. So what is this isomorphic? So isomorphic is an invariant of the simple graph, so which is going to existence of simple circuit of length k, where k is an integer here. Normally, the two graphs are said to be isomorphic whenever there is an existing edge which is going to be coincide of the other. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.